us write down again direct variation. After all that, it's really hard to get back to class. But one thing you'll find is you're probably less tired when you actually have a normal day than you have a day when you don't do anything at all. Anybody found that one truth to be self-evidently true? In other words, sometimes when you sit at home and don't do nothing all day, don't you sometimes feel tired at like 4 o'clock than when you actually go to school when you're done with school? Is that just me? See, Colin? We see the real picture here. All right, remember this. Talking about direct variation. What was the deal with direct variation, since you said we already talked about it, and we did it here. When you're making a table, we had something we called what? Doesn't matter. Let's just say this. Let's say you are talking stamps. And stamps cost, everybody know how much a stamp costs these days? Somebody even mailed anything before? I don't know, they're like 45 cents or something like that, are they? Does anybody know for sure? 45 cents. So, if I asked you to write an equation using x and y's with stamp costing 45 cents, you would probably tell me that the letter y, which is how much money you pay, is going to equal what? 45 cents times what? How many stamps you buy, right? Number of stamps times 45 cents equals total amount of money. Does that make any sense to anybody? X and Y. So you buy no stamps, you pay no money, which is good because one of the things of direct variation, which is the same as being proportional, is that when one is 0, the other one is 0. It has to go through the origin when you do it. All right, if you buy one stamp, it's going to be 45 times 1, which is 45. 2 stamps, 90. 8 stamps, somebody, 360 cents. 10 stamps, 450 cents, correct? All right, and when we talked about this, we talked about in order for things to be direct variation, they have to have what we call the constant of proportionality. And in that case, Noah Clausing, the constant of proportionality is, what do I multiply everything by always? What am I multiplying by every time? Yeah. So your constant of proportionality, which we use the letter K, why don't we use the letter C? The C already has some MC squared. Everybody know Einstein's theory? What is that?
Mass times something.
Somebody, yeah, what is it? Who
There's
said it?
mass times something.
It is. What is the letter C in math is usually designated for the speed of light, actually. Speed of light. So we don't use C, we use K. And the constant of proportionality is 45 cents. So there, everybody's kind of happy there. And I suppose since we're talking about this, we have lots of time, and you don't really care. If you were graphing this, you know, you can make a graph out of this real-world situation. The x-axis would be what? What is this axis? No, we're not. When I wrote this equation, what did the letter x stand for? How many stamps? Number of stamps you bought. So here is 1 stamp, 2 stamp, 3 stamp, 4 stamp, 5 stamp, blah, blah, blah. The y-axis stood for, what was y? What is this? Yeah, how much money you paid. Cash. And then we'd have to kind of make some things. Maybe we go, what would I do? 20, 40, 60, 80, 100, whatever. You know, 0 stamps cost 0 cents. 1 stamp cost 45. 2 stamps cost 90. And it's this nice straight line that goes up and like that. Does that make any sense to nobody? Doesn't make it. Now, write down this problem because what you're doing, we did do direct variation, but today we're actually doing problems that have direct variation. And hopefully you'll get like at least one small tidbit of thing. Ellen charges for food directly as the number of people that attend. Write that down because we'll talk about that. Ellen charges, we don't really ever say this, for a banquet event are directly proportional to the number of people that attend. Directly proportional to the number that attend. Now let's break that apart here just for a second. What does that mean? This lady runs her own catering business. Would it make sense for her to charge directly proportional to the people that attend the thing? Does it make sense that if 0 people go to this banquet, you're gonna get charged $0? Does it make sense that if 5 people come and she charges $50, that if 10 people come she charges $100? Does that make sense? Would it seem to make sense that if 1 person comes she charges $10, but if 100 people come she charges $5? No. Usually things are directly proportional. As one goes up, the other goes up. And it says, Ellen charges, those of you that are getting ready to plan out your wedding ceremony, you want to know this. Ellen charges $780 for 60 people. How much would she charge for 100 people? How much for 100 people? And this, children, there's a bazillion different ways you can think about this and do this. They want you to think in terms of being directly proportional. So one thing you can think about is this. Here's my table. I know that if it's directly proportional, you can automatically fill this in. That if 0 people go, how much is she going to get charged? No dollars. And the other information I have is that if 60 people go, she's charging $780. And the question I have is that if 100 people go, how much money is she going to charge? Now, because this is proportional or directly proportional, it's just like a ratio box, and you can figure it out like a ratio box. They want you, though, to think about the constant of proportionality, which means they want you to figure out what do you multiply x by every time to get y. Y equals what times x? That's our little constant of proportionality. So you'd have to say, well, what times 60 gives me 780? Anybody good at math in here at all? We did take first as a team at the math contest. I was thinking that maybe somebody. Cameron Atkins says he thinks he knows the answer. Huh? $13. Yes, that is exactly it. That is your constant of proportionality. Whatever x is gets multiplied by 13 to figure out what y is. If only 1 person showed up, $13. I scarcely believe that this nice lady here would do an event for just 1 person. Why? Because I'm not thinking she's making a lot of money charging $13 for just 1 person. You know, the deal with this is you do it for a lot of people, it makes it a lot cheaper. Because, I mean, for $13, she's going to make this in some kitchen somewhere, drive it all the way out to this place, and drive all the way back, and then clean up when they're done cooking. So, what would 100 people cost then? Once you know the constant proportionality, you can just keep doing it over and over again. 100 people cost, Brooke Holla? If the constant of proportionality is 13, I'm multiplying this times 13 every time. What is 100 people cost? Yeah, $1,300. What would 20 people cost? Somebody help me out on here. So we'll just let them cool, and then I'll have my kids cut. Is there a secret to cutting? My wife says use a plastic knife.
I have no.
Alright.
You're on your own.
Thank you so much, Mrs. Smith.
You're welcome, and be sure and thank the girls because they did a great job.
I will thank them personally. I may even write a letter. Somebody says I'm landing.
260.
Yeah, $260. And hopefully you can see that's the same thing we did when we did ratio boxes. If I took any of these, let's say I just put 60 over 100 and said that equals 780 over what number, it's all going to be a wash and going to be the same exact thing. You know, 60 times 13, 100 times 13. Or reduce this to 6/10. Or reduce it down to 3/5. 3 times whatever, blah, 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 blah. Just know that directly proportional can be solved doing tables, can be solved doing ratio boxes, proportion boxes. You say, let's try one more.
Let's try one.
Let's try one that's harder.
Let's try one. Okay.
So let's say you've got this. Here's the problem. Driving at a constant speed. By the way, when you see that word constant, think about the constant proportionality. Driving at a constant speed, Maggie this is right out of the book, by the way. Travel varies directly with the amount of hours she drives. And that only makes sense again, right? The number of hours you drive, the farther you're gonna go. Constant speed, Maggie drives 75 miles in 1.5 hours. Maggie drives 75 miles in 1.5 hours. How long does it take her to go 100 miles? How long to go 100 miles? Mucho different ways you could do this. Maybe it's best to start off just drawing yourself up a table. You know, X and Y, I guess you gotta figure out, would X be the number of hours or the number of miles? Do you take the number of hours and multiply it by something to get the number of miles, or do you take the number of miles and multiply it by something to get the number of hours? Which one is your input number when you're talking about speed? Which one makes sense that you multiply it by to get the other one? Maggie says, yeah, X is going to be hours, however many hours you are, and Y equals, I'm sorry, distance. That's the distance or speed. Distance. We know that Maggie, in 1.5 hours, 1.5 hours went 75 miles. In 0 hours, Maggie is going to go 0 miles. The question was here, how long will it take her to go 100 miles? Make sure you fill in the blanks with the right things. Don't put 100 here, because it wasn't 100 hours. Any thoughts or suggestions? If you were solving this, what would you do? Or how do I know, how could I find out what the constant of proportionality is? How could I figure out what I multiply this by to get that? Taylor? Yeah, you just say, okay, if I have 75 divided by 1.5, what does that give me? It's 1.5 and 750, which is what? It looks like 50. Yeah? So that means your constant of proportionality is 50. Whatever x is, you multiply by 50 to get y. Well, unfortunately here, I have y, so to go back, what am I going to have to do? I don't multiply that by 50. Somebody? Divide by 50, yeah. 100 divided by 50 is 2. It will take this person 2 hours. Look, children, David's here. Wait, did you just get here to school?
Yes.
You missed all the fun and excitement of all
You
the...
didn't want to do it. Someday.
To what?
My grandma and my aunt are here, so last
Oh, okay. I was just saying, this is like the first thing, constructive thing we've even done. Alright, let's do one more and then I don't know, I'll set you free. Look at, oh, you're not on the book. Well, some of you are. If you're looking at example 3, it says, there were 23 people in line in front of Delia waiting to be helped. 3 minutes later, there were 18 people waiting in front of Delia. Predict how much longer Delia will help to be waited. I'm not going to write the problem here, but here is generally the gist of what you're thinking here. So here's my little table. What are we trying to figure out? What is our ratio about? How many people are getting helped per what? What's the time? Brooke? Yeah, you're looking for people per minute. PM, not a rate we usually do here. So if you're thinking about X and Y in your table, okay, we're talking about people and we're talking about time. Okay, do we multiply the number of people by something to get time, or do you multiply the number of time by how many people get helped? Somebody out there in the world there, predict how much longer. In other words, it says in 3 minutes, the line went from 23 down to 18. How many people got helped in 3 minutes? 23 down to 18 means, Alex?
5 people.
5 people got helped. Do I put 5 here and then multiply it by 3, by some number to tell how many people were helped? Or do I multiply the time by something to get how many people were helped? Which one is this time and this people, or is this people and this is time? Maggie says, yeah, time. In 3 minutes, how many people got helped? 5. In 0 minutes, how many people would get helped? 0. But the question is, when will this person get helped? So how many people have to be helped before this person is next? Somebody? How many people are they behind? Andrew? 18. So that goes here. You want to know how long it will take at this constant to help 18 people. So you could figure out the constant of proportionality, which isn't going to be a nice number. 3 times what number is 5? Anybody want to speculate?
15.
No, 3 times 15 is not 5. 3 times 5 is 15, but 3 times what number is 5? Well, what did we do the last time? Divide them. So you're going to do that again. If you're doing it this way, 5 divided by 3 is 1. Does it work out? Why doesn't it work out?
No, I'm sorry.
Let's just do it as a fraction. How many times is it? What, 2/3? 1 2/3 people get helped per minute. So what do I do with 18 to come back this way? What am I going to do? What did I do the last time? Divide it. So I'm going to take 18 and divide it by 1 2/3. Or, like I said, you could just write this out proportionally. 3 over what number equals 5 over 18. Look how nicely that works. Equals 5 over 18. And if you do that math, guess what you get? Cross products, 5n equals, anybody 3 times 18 in their head? Sure, 54. Divide by 5, divide by 5. N is going to equal 10 4/5, or 10.8. That would be how many minutes it's going to be before that person's helped. And then the question of the day, to whether you get all or just half the assignment today, Caitlin Shellhammer, is this. And this, everybody has to answer this. Let's go. I'm only going to have 6 people. If 6 people get this question right, 6 people. Oh, I can't. Oh yeah. Yes, 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 I will do. I will do this. Here's the question. 10 4/5 minutes, or 10.8 minutes, is how many minutes and how many seconds? In other words, all I need you to tell me is that 4/5 of a minute is how many seconds. I need 6, and you have to write it down and circle it on your paper. 4/5 of a minute, which is what this is, 10 minutes and 4/5 of a minute. 4/5 of a minute is how many seconds? 4/5 of a minute is how many seconds? I know it's difficult. 4/5 fifths of a minute is how many seconds?